We do additional work in the room. We get ready for the next order. We clean stuff in there. There was no safety curtain around the blender either. So, I mean, somebody can walk around the blender, here comes the blender around, and I don't know where the guy is going to go. So, safety should be your number one priority.
Absolutely.
I operated on safety, quality, appearance, reliability, and cost. That was my motto. Those 5 things.
Okay, ribbon blenders. I said a while ago nobody uses a ribbon blender today, but they do. Ribbon blender typically isn't used for final blender, but it can be. The blend times are typically much longer. It takes a long time to get the lubricant, and the ribbons are of many different designs. You can see here that not all ribbon blenders are created equal, and so having the technology or having multiple blenders may create a problem. Here's that tote blender in the juxtaposition used as the final blender. And so in summary of blending or final blending is that not all granulators are good blenders, not all blenders are good granulators, that's for sure. And granulating and final blending have different goals, completely different goals. Granulating is to make a granulation, blending is to create the final blend and to give us that lubricant addition. Yes?
Do you get better blending through a tool blender versus a ribbon blender?
I can't say better. I can say that a ribbon moves products across themselves, that the ribbons are moving and mixing in this kind of fashion. Whereas a tote or a tumble blender is allowing powders to bounce or ricochet off the wall. So if you have a product that has good flow characteristics, it's nice granulation that moves well by itself, it would probably work better in a tote style blender. If you have a product that doesn't move and you need something to push it, then you need the ribbons to move or motivate the product. Those would be the 2 metrics that I would use to evaluate that.
Question for you, Mike.
Yes.
We talk about blending and all this technology, but how do you transfer it out of the blender and keep it homogeneous?
You weren't supposed to ask that question. He's asking, okay, once we transfer the product out of the blender, just because we have a good blend doesn't mean it's going to stay a good blend. And that's really a really acceptable thing. That is, I could have a great blend, dump it, discharge it into a container, and just leaving it sit for a little while can cause a problem. Transferring it, I've got customer clients that have a long distance between blending or sometimes different buildings where they take the powder and they put it on a truck and they move it down the street, and that vibration causes settling, deaeration, causes segregation, and so by the time that blend gets to the press, it's no longer a good blend. You know, or that the press is set up to run incorrectly, and we have a good blend, but we run the paddles in the feeder very too quickly and cause segregation. So we can create a lot of problems for ourselves. So his question is, how do I avoid that? You obviously, the word is, it's impossible not to, first of all, you have to identify where the problem is to figure out how we can build this into the system a way to avoid it. I mean, there's no way for me to stand here and say, stop blending early and let it finish it blending itself. That's not how it works. And managing the product and the powder for its characteristics, because a lot of companies say, oh, we blend everything 2 days in advance. Well, that might not be good for everything. That might not be a good practice. Some powder, like water, it can move back and forth. It looks exactly like water. It moves, it floats until it deaerates a little bit, and the air comes up out of the powder and actually percolates up out of the powder until it settles down a little bit. It's actually too fluid. If you took that powder and put it on an encapsulator or on a tablet press right off the blender, it would not probably perform well. We can't tablet or encapsulate too quickly out of blending. There is a period of time we have to wait for a little deaeration, for it to settle a little bit. Some products are so sensitive to static electricity that if I don't discharge the static, the product kind of sticks to the walls of the blender, hangs up, won't settle down, so I have to put some kind of grounding strap on there. And what in reality is, this is what happens. You're walking over, you have to get that drum of material, and you see a rookie coming by, and you say, hey, check that label for me. So the guy goes over and he touches the blender, he gets an incredible static electricity shock. He goes, wow, and you go, thank you very much for doing that, and now you can grab your blend. That's actually very normal. The scary thing is it just told you a story. If your powder is to the point where it's zapping you and you're not doing anything about it, that means there's static in that powder. If there's static in the powder's not flowing as well as it could. So if you're not discharging the static, you're getting static discharge to your buddy, your operators, to the rookie in the building. I just told you something, don't do, right? You know, don't go there, right? Okay. Any other questions about blending? All right, a couple of things about, we're right on time. A couple of things about milling, and we'll take a look at the equipment, and that'll be time for a ball game here. Beer 30. Beer 30. Okay, so what we're going to talk right now is about the role of mills and what they're used for, and you know what happens with mills and different types of mills. We use them to improve flow, reduce segregation, to enhance drying, to control particle size, and to give us consistency batch to batch. So I'm going to demonstrate each one of these. So where are mills used in the process? So we know how they're used and why they're used, but where? Well, we use them in the way up. That could be the screener. We can delump. We can achieve a good particle size distribution. We can use it after or before granulating to deagglomerate. We can dry mill to prepare dry additions. We can delump later on, or we can reclaim off-spec tablets. So we can use mills in many, many steps in the operation. And when I say milling, I mean screeners, I mean high shear mills, I need low shear mills, I need anything that's going to delump or classify or break down powders. So milling issues and characteristics, different materials have different characteristics. This is definitely an herbal product. I don't know if it's illicit or illicit, but we're taking an herbal product and trying to turn it into a granulation that's going to be usable either to go into a capsule or into a tablet or some kind of other medical device. So I can have materials that are tough or friable or plasticky. I have issues with fines, that is dust control. We already talked about that. The fines create defects or specks that create a need for dust collection, and noise is an issue with equipment, with mills and different types of mills. So we're going to run through some of this. So where am I going to use it? I'm going to use it to reduce coarse materials to a smaller uniform particle size. I'm going to use it for oily or waxy products. That is, if I have a mill, there's no such thing as one mill does it all. This particular mill, this is a blade with a sharp edge. You guys would know it as a Fitz mill with a code 225 blade, a sharp edge blade. And your procedures would say knife forward, right? Knife edge forward. That's that sharp edge forward. But what I see here is product buildup on that blade. As product builds up on that blade, that's going to change the dynamic of how well that blade's going to work, right? If all of a sudden I got a lot of buildup, it's not going to break down the granulation the same. That's telling me a story. That's telling me that I got product that's locking up, I might not be using the right mill. I might, instead of using a high shear, I might need to use a low shear. I might need to use a different type of mill. So a lot of people say, well, how do I know it's doing a good job? Number one, look at the blades. Number two, look at and use a sieve stack to check out the particle size distribution when you're done. Evaluate if it's producing too many fine particles. Evaluate if it's densifying the granulation or compacting it in any way. Then you're going to know if it's doing a good job. Because our products are so varied. I can have something that's, you know, a dispersion like a lumpy product that I just want to get uniform. Well, I wouldn't use knives to break up that. I want to do something gentle. Same thing with agglomerates that I already have or particles I already have. I don't want to produce dust here. I just want to break up those agglomerates. I want to be gentle. So sometimes using a mill or the mill correctly is being gentle, not being overly aggressive. If I have something like a salt or something that's tough, I have to use something that's aggressive. I have to have a shear force or the ability to really tear up that product. So it depends on the characteristics. Tough product, I need something that's really going to get after the product. If I've got a granulation that I made that's wetted granulation, I'm going to take that granulation and I'm going to mill it carefully. Okay, I can, if I do it right, I can reclaim capsules. I can crack the capsules open, collect the product, separate the gelatin from my product and reuse that product. So I can do it right if I measure the types of forces that I use, the type of the hit, the blade of the hammer, the velocity of the blade, the way the screens are set up, into the impact, where it's going to go and how it's going to get out, and how quickly it's going to get out, all are a huge part about milling. And the funny thing about mills are that one thing that people kind of push around and they grab anybody to run a mill. Just run the stuff through. So if it's Monday morning and my job is to mill and I got all day to mill, I'm going to kind of scoop into the drum and I'm going to mill very slowly because I got all day. It's Monday. If it's 4:30 and I got a baseball game to go to, you know how fast I'm going to mill? Am I going to get a different product? Absolutely. So feed rates are part of that, and the characteristics of the material are part of that, and controlling the fines are everything. I already showed you this slide, that we really want to control how many fine particles we have and what our distribution is. Fines, can you read this in the book? Can you read those lines in the book? All right, good. So fines are particles that are smaller than 200 mesh. So what do fines do to us? It dries the oil in the punches. That is, when you run in a press, every time you make a tablet, air leaves the compression zone and a small puff of super, super fine dust gets airborne. And if we used a strobe light, you would see a smoke ring, a little puff. Every time you make a tablet, that air's got to be displaced or go somewhere, and there's a perfect little puff. And you can see it when you walk into your plant and you look on the doors on the machine or on the walls, you see that super fine dust. That's from compression. That's why we need dust collection. That dust gets on the punches and makes the press, that's what makes us have to stop and clean the machine. It can affect the ability for the lubricant to lubricate the proper, that is the magnesium stearate, to be effective. The higher the percentage of fines, another way to put this is, the higher the percentage of fines, the higher the percentage of lubricant you need in your powder. The higher the percentage of magnesium stearate you need. So if you have a high percentage of fines and you need to increase the percentage of magnesium stearate, what does that do to your dissolution profile? It extends it, because the more mag I have, the longer my dissolution is. So I want to use a minimal amount. Fines work against me. They affect yields. They create capping and laminating because they don't flow well, they don't compress well, and they hurt me in the area of content uniformity because they hurt the flow and the ability to mix the powder. So fines are my enemy. I have a friend of mine that says that I have it tattooed on my chest. I guarantee you I don't, but He always claims that I do. You agree? Okay. Okay, so let me start with a couple of different types of mills. A quadricle mill, and we'll look at one of those in just a second here, uses an impeller, uses a cone type screen, and it's a sweep, and it's a fairly gentle action in comparison to a higher shear mill. It can be used for wet or dry powders. It can be used for large particles or small particles. It's not as sensitive to producing a lot of dust. It's a good technology. It's not as sensitive to feed rates. You can pretty much feed it and it won't create a problem because the screen is 360 degrees. So as soon as the powder gets to the right size, it comes out. The downside to a cone mill is it's not good with tough products. It's not good with abrasive products. It's great for granulated products. It's great. It doesn't have super high capacity as compared to some of the higher speed Fitz mills, but both machines are needed. In the pharmaceutical suite, we kind of have a high shear granulator setup, a fluid bed, and a final blender. So what I've got here is, here's my high shear granulator, just like that one there. And then it's transferring through a mill, being vacuum transferred directly into a fluid bed dryer. That dryer then vacuums back through a mill and into a final blender. And then the final blender would be brought to the press. So that's a classic closed system using milling in a manufacturing suite. Mill before I granulate after I mill, transfer it to a fluid bed, mill before. Anybody use one of these?
What kind of noise does it make?
Huh?
What kind of noise does it make?
Yeah. Hey, anybody here ever seen an oscillator? They're a great machine. I use them. Here's a little, there's a Adam Federal Equipment here has a bunch of small little oscillators over here on the floor. It's a great little machine. Peter just said, what noise does it make? Because that's the giveaway for an oscillator. An oscillator is nothing more than a device that oscillates over the top of a screen. And usually you can hear an oscillator about 200 yards away because you hear, and that's literally the hexagonal bars here pushing against the screen to push the product through the screen. I don't know where the metal's going with it, but
Why don't they call it an oscillating mill?
why? Because it actually, oscillation means it's going back and forth.
No, I'm saying rather than calling it a granulator.
Oh, yeah, that's a wonderful question. When I worked for Stokes, I had that argument all the time. This doesn't granulate. You're exactly right. But Stokes called it that. So everybody's kind of stuck with that terminology. But I'll pass this around, just pass it back. Look at the surface, and you can feel where the metal is actually, and really, the machine's being used wrong. If the machine were used right, what you do is you stretch the screen and then back it off, and it creates its own gap. And there should be no reason for that metal-to-metal sound if they're set up correctly. Ultimately, what this picture is of the punch heads on a tablet press. Can you see real close? If you look close, can you see little pits on the surface of those punches right here? Can you see that in the book? Those pits, pardon me, where do pits come from on tooling? That comes from the granulation getting between the surface of the punch and the pressure roll. Literally, the powder is getting pressed into the steel, creates metal fatigue. The higher the percentage of fines, the more likely that's going to happen. Something like this is very gentle. It doesn't produce a lot of fines. It's a great way to make a product. So the thing we're passing around here, you can see the hexagonal bars and you can see the wear. The next technology is a Fitz mill, one of the most common types of mills used in pharmaceutical manufacturing today. It can be used with many different types of blades. It has a 120-degree discharge to get the product out, and that's good and it's bad. It gets the product quick, but if I choke feed this at all, the product builds up all the way up into the center of the machine and doesn't discharge well, and it can create problems. It can create compaction. So I have to be very, very careful about feed rates with a Fitz mill. Very consistent. The more consistent I am, the better product I'm going to get off the mill. There are different types of blades or apparatuses to control your particle size on this technology. A couple of quick notes. Number one, so with some products, your operation procedure is going to say blunt edge forward. Blunt edge forward means that you're pulverizing the powders. That means that your powders are not super friable, because if I had a really friable product and I hit it hard, it would blow it apart and create a lot of fines. So if I have a super friable product, I really want to use a knife edge to cut it and give me control particle size, not blow the particles apart. So that's what that picture is showing me. If I have a product that's a little bit more forgiving, you know, I can use it there, but otherwise I have to use a knife edge. And a lot of times, probably a good percentage of the time, we're using knife forward. The problem with knives is they wear out. If you only have one mill, as those knife blades wear, they get rounded and they become more like a blunt edge than a cutting edge. And so they have to be replaced. And with the flat edge, if that becomes rounded, it's not going to be the same blade. So blade condition is very important. Different types of screens, perforated plates to achieve the final particle size. And a couple of things about aperture and RPM. First of all, if I have a given RPM, that creates a trajectory through the screen. So if I have an opening in the screen, say I have this 20 mesh screen, and I have a certain RPM, I'm going to get a particular given particle size. If I increase the RPM and change the trajectory, I'm going to make a smaller particle. I'm not just increasing output, because the trajectory flattens out and I end up with a much smaller particle size. Really important thing to think about when you're establishing feed rates and machine speeds, is you need to note what speed you're at. The other thing that really drives this point across is different gauge screens. So if I have the given trajectory, I have established my speed, but I go to a different supplier for a screen or a different type of screen, and I have a thicker opening, I'm going to end up with a smaller particle size. One of the things that we see a lot is when we go to a company, they'll have a reserve of screens, and they'll be all marked 30 mesh or 18 mesh or whatever. And we start micing them and see different thickness screens, quite a bit different. You don't even have to measure them, you can see it. And they're not really, those screens aren't numbered a lot of times. And if you don't number those screens, then you can't relate, if something happens to that screen, to the product. Are you required to do something like that? Mm-hmm. Yeah. Yep. Okay, so product addition becomes a huge thing as well. Feed rates I've already established. So typically, most machines in our business, the Fitz mill is a pan-fed unit, looks just like this. It's up to the operator to feed product in, scoop it in with that pan feed, or we use an auger feed delivery. An auger feed gives you better feed control. There's a number of different types of feed throats. That is, you can have an overhead feed, you can use vacuum or use process to drive product into the mill. You can use an auger to bring product in. So there's a lot of different ways to feed product in. It's just important to know that if we don't control feed rate, we can end up with a problem. The systems, as we talked about with granulators and other equipment, this type of technology is available with product containment as well. And for those of you that are antiques like me, one common mill in the industry used to be a tornado mill. The same guy that developed the Fitz mill built a tornado mill. He took the blades and turned them this way, had a 360-degree screen, and actually it's quite a good mill. It was made by a different company, not marketed the same. You don't see as many around, but they It actually does an equivalent job. It's a very good design. There's a big caution here. This is really important, that any time with machines with three-phase power means the phases can be crossed if the machine's moved. That is, that means that any machine you have to check rotation. That if I took that tablet press and went over and plugged it in at one outlet, just because it's set up for that machine, if I go plug it in someplace else, it might run backwards. So we always have to check rotation. Now, tablet presses are pretty well dedicated to a particular area or rooms, but mills aren't. And a lot of times people move mills, they create a room here, they plug it in, and the mill starts running the other way, and you can't tell. Unless you look for rotation, you can't tell the difference until you start putting product in and it starts coming back at you. And it doesn't mill the same way. And it sounds funny, but a lot of companies make this mistake. They're trying to force product into the mill when it's running backwards, and they can't figure out what the problem is. So that's a safety issue as well as a operational issue.
One of the issues is what we see in most of the companies. You got cleaning SOPs and you got cleaning documentation. And usually you have all the documentation for the mill itself. So if I'm an auditor, I'm the other guy from the agency, show me your cleaning documentation. You can show them what you did to clean the mill. And that's why the question came before, is it required to number your screens? Usually you got multiple screens the same mesh size, but they're not numbered. So you can run into the situation that the FDA is going to tell you have no proof of ever cleaned a screen in this mill because it's not numbered, it's not tracked. I don't know which screen you use for the product, and you can come in a real big predicament there.
Huge.
Huge, because you mill a lot, that means you have a lot which is not good anymore because you can't prove that the screen in the mill was cleaned.
Yeah.
So I always recommend you get multiple screens, you have to have a logbook for the screen itself where you can say, yes, this screen has been cleaned and it's been used in the mill number 15. A lot of companies don't have it, so be careful with that.
Very good. Thank you.
Question on Tomo screens.
Yeah.
How do you know when they're worn out, or what's the best practice for understanding when they're end of their life?
Oh, the question is, how do you know when a screen is worn out? Not necessarily just a co-mill, but any screen, right? I mean, a lot of the different surface, first of all, I use the word screen pretty loosely. There are perforated plates and there are screens. A screen indicates a mesh size. But typically when we talk about using screens on a mill, it becomes a generic term. So if I say, grab me a 18 mesh screen, or your batch record says I'm using a particular mesh size, it may be a screen or a perforated plate. Okay, so a lot of people don't differentiate. That's important. So this is an excellent question. So the question really is, how do I know when those screens are worn out? Well, a lot of fine screens break. One time we were at a facility and the screen broke and they passed the product back through a metal detector, found metal. They passed the product back through the metal detector, found metal. They passed it back through the metal detector 2 more times, didn't find any metal. And then the decision was made to scrap the material. Didn't agree with it. They approved that they found it all, but somebody said you have to reconstruct the screen, and that would be next to impossible. That's not true. But everybody reacts differently. So if you break a screen, that's very obvious. But then if you break a screen, there are steps to take place. If we're in a perforated plate where it breaks screens because of all granulations are abrasive. Some are more abrasive than others. If I'm making a calcium tablet or a nutritional tablet that's oyster shell or calcium, that's incredibly tough and it goes through screens really quickly. But the only way I know, to answer your question, the only way I know to determine screen is a visual inspection, screen condition. The only way I know is that you can simply see tattered or worn screens to the point where they're coming loose on their frame, where where two pieces of wire crossing themselves, where they're frayed, or where the holes on a perforated plate are becoming elongated or misshapen. Yeah, that's the only way I know how to do it. Yeah. Yes?
You didn't talk about roller mills. What do you think about those?
Oh, sorry. Well, I intentionally don't talk about them because you don't typically see a roller mill used for tablet compression or for encapsulation. Typically, a roller mill is a fine grinding mill, a mill that's typically used to produce a much finer product. Say I was going to put a component into suspension, you know, like a color or something like that, where I'd really want to break that up or fine grind it, I could use a roller mill to do that. But typically roller mills produce too fine of a product, don't give me the category, the classification that I need for tableting. Great question. Anything else? Excellent. You guys were great today. It's been a little warm in here, huh? But this is great. I mean, this has turned out to be a really nice setup. What we're going to do now, we're going to, guys, grab something to drink. We're going to head over back to the line of equipment, talk a little bit more about that. Yeah, Adam?
We also have Klondike bars, ice cream, if anybody wants.
Do you really? This is the nice thing about this facility is that you can actually walk around with a Klondike bar around production machinery. Yeah. That's unique. We're going to take pictures of each of you. No hairnet. What's that? What did he say? All right, we'll see you back there in 5 minutes or so.